This new AI helps scientists quickly understand complex brain data. It's a huge step towards unlocking the secrets of intelligence. Let's get into it. Let's start with a featured paper, SeekBrain, an autonomous multi-agent system for accelerating neuroscience discovery, by Jiamin Wu and Chunfeng Song from Shanghai Artificial Intelligence Laboratory. Here's a full breakdown.
Here in panel, we see the overall SeekBrain workflow, which is the core of our autonomous framework. It takes a research query and multimodal data as input and ultimately produces a full report and figures as output. Feeding into that workflow, the process begins with the research planning engine. This engine takes the initial research query and breaks it down into a more structured research plan with specific subquestions. To get the necessary expertise, the system uses a crystallization agent. This agent extracts information from scientific papers and code to synthesize structured analysis recipes. Next, the analysis execution engine takes over, using these recipes to carry out the plan. It uses its own team of agents to perform the analysis task and produce the final analytical evidence. SeekBrain significantly outperforms both Claude Code and Codex across a range of neuroscience tasks, achieving higher mean scores in overall performance and various task categories. This superior performance is consistent across easy and hard tasks, and is also reflected in better figure fidelity, method correctness, and interpretive validity.
Up next, our second paper out of 3, FriendBench, Benchmarking Dyadic Familiarity Inference in Humans and Multimodal Large Language Models by Jeffrey M. Gerard and Benjamin Pelequin from Fluid Concepts Research. Let's break down its key contributions.
To begin, we introduce FriendBench, a new benchmark for evaluating how well AI can infer familiarity from conversations. This table lays out the various models we tested, organized by the type of information they use. The system processes short, 20-second conversational clips by leveraging information across multiple modalities. We analyzed the transcribed text, the raw audio. Next, we conducted an extensive comparative analysis, evaluating 26 different models from a range of developers. The table shows this diverse lineup, from OpenAI's GPT series to Google's Gemini and many others. Our analysis reveals that performance differences often come down to the model's internal process, which we detail in the reasoning column. For instance, we tested specific variants like Gemini text thinking that employ a dynamic reasoning strategy to see how it affects outcomes. Finally, to encourage further research in this area, we are making our resources publicly available. This includes the conversational stimuli, the collected human ratings, and all of the model predictions. The models, including the best model, consistently outperform both the human crowd and individual human raters in accuracy across text, audio, and video modalities. All evaluated methods demonstrate performance substantially above the chance level, with the best model achieving accuracies generally in the 60 to 75% range.
Up next, our third paper out of 3, Harnessing the Wisdom of LLM Crowds Through Complementarity-Driven Iterative Collaboration by Yanbin Fang and Wei Chen from Business School, Chinese University of Hong Kong, Shanghai, China. Let's break down its key contributions.
On the right, we introduce our WILC framework, which uses what we call relay-style complementarity. Instead of having models work in parallel, Model A, our medical expert, first creates a solution that is then passed like a baton to the next model. This relay process enables an iterative refinement workflow, where the initial solution for Model A is diagnosed for weaknesses. The identified bottleneck, in this case, the flawed code syntax, is then passed to Model B, which refines it to produce the final collaborative solution. Governing this whole process is our model selection mechanism, which decides when and to whom to pass the work. This is represented by the relay point, which acts as a gate to identify the bottleneck and select the best expert. Here, Model B, the coding expert, to resolve it. The WILC method achieves the highest average performance of 87.78. This significantly outperforms all other methods, including various single execution, react, reflection, and self-ensemble approaches, as well as the heterogeneous ensemble.
Those were the top papers. Now, let's zoom out. ArXiv received 520 new computer science papers across 54 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: LLM frontiers, math, data, bias, autonomous AI agents and reasoning, LLM evaluation and critical use, multimodal AI, adaptation and alignment, efficient algorithms and optimization. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.